Okay, welcome. Today I want to show us kind of a review of what we've been talking about, but how to come up with exponential functions and also how to graph them. And finally, I want to show us where two exponential equations meet. Okay? So first, we need to look at this, both counties to come up with a formula. So if you read this, County A has an initial population of 4 million and it increases 3% every year. County B, on the other hand, has an initial population of 10 but decreases. So right off the bat, I'm thinking when I see increases, I always think of growth. You want to think of growth. Now, with that being said, I want to take and I want to come up with a good equation. So I'm going to use population, and then my variable is going to be t for time. Now, remember our initial population is, remember when we talked about and we said, okay, like this could be P of t equals A times B to the x power. And this is how the exponential would look like. Well, our initial values always are A value. So our initial value in this case is 4. I'm going to put 4.0. Okay. Now what I'm going to do is I'm going to say, I'm going to put a multiplication symbol because exponential, you're going to multiply. Now we're going to try to find what the growth factor is. Now it's a growth factor because it increases. So if you can recall, it's 3%. You want to just divide it by 100. You should get 0.03. And since this is a growth, you want to add 1. And this is what our growth factor is. That's what our B value is. It's 1.03. Okay, now this is going to be raised to the t power because we want to say after t years. Okay, next. Now we want to look at how to come up with an exponential equation for County B. So let's look at it. So now this is going to be P of t equals, the initial value is 10.0, but now it's not an increase, it's a decrease. So what you want to do now is you want to take 1, I'm going to say 1.00, subtract, okay, what is 6%? Well, 6 divided by 100 equals 0.06. So you want to subtract 0.06 and you get 0.94. And since that's less than 1, we know that is a decay. And we want to raise this to the t power. So these are both of our equations. Now, just kind of review, our initial is at the beginning, and the growth will have a growth factor that's greater than 1. In this case, it's 1.03. The other one is a decay because it's less than 1. So now what we want to do is we want to graph these equations. Now, what I want you to do is I want you to look at your graphing calculator, and what I want you to do is I want you to see your y equals at the very top. So when you hit y equals, you're going to see y1, y2, and a bunch of them, but we're going to just use y1 and y2. And all I'm going to do for y1 is I'm going to put 4.0 times 1.03. Now this time it's going to be raised to the x because our calculator does not read to the t. So it's going to be to the x. The second one is going to be 10.0 times 0.94 to the x. So once you type these into the y1 and y2 values, then I want you to hit your second button. That is on your calculator, your top right. It's usually it's going to be a blue or an orange. It's going to be a colored button. So I want you to hit second, and then I want you to hit graph, which is at the top under the screen, the top right. And what you come up with is a table. You'll see your x values. Your y1 is what we defined as that's our 4.0 equation, and our y2 is our 10.0 equation. So if you go up and down the x values, you could see the different values what x can be. So in part C, it's going to ask you the first 15 years, and then label the x and y values. So it wants you to graph them. So I kind of went ahead to save us some time, but I'm going to show you what I'm doing. So the first table is for county A. So that's your x. This y is your y1. So if you look at your table, when x is 0, y is 4. When x is 1, y is 4.12, all the way down to when x is 15, y is 6.23. Now I've rounded these to 2 decimals because later on in part C, it's going to say round to 2 decimals. So then all I'm doing is I'm going to go ahead and I want to graph by the blue dots 0, 4, 1, 1, or 4.12, number 2, 4.24, all the way to 15 and 6.23. Now mine are not exactly perfect because I don't have graph paper, so it would be probably, if you want to be more precise, you should get graph paper to graph these. So what this does is this, I'm going to make this a different colored line. So basically this is connecting the dots. And eventually it's going to curve up because it's a growth. So as time goes on, it's going to eventually go up exponentially. So now my green dots, so I'm going to put green. My green dots represent the county B. Now notice one thing I want to show you how to label these. My bottom number, it says label the x and y values. Well, first of all, this right here are my years. Now notice they're 1 through 15. This is my population. And that's in million. So what I've done in the population is I've went up by half, because if you look at both of your data points, you know, I'm just going up by 5 or by half. I mean, if this is up to you. You could go up by quarters, you could go up by tenths, however you want to do it. But this is to get a little bit more precise. I'm using half, but if you want to continue to get more, you may use, you know, mark them off in quarters. Now, look at your y2 values. Notice it starts at 10, so it's 0, 10, 1, 9.4, all the way to where, if you look at 15, it's 3.95. So I've went ahead and I'll make connecting the dots. So eventually, this will hug the x-axis as it approaches 0. So as the time goes on, so when you hit 100 years, 200 years, eventually it's going to go all the way to 0. It'll never reach 0, but it'll come close. So I've showed you right here how to find your equations, put them in to find your tables, graph them, label your graph, and finally, part D, it says, when will the counties be the same? What value will that population be? And round to 2 decimals. Well, this kind of review what we've seen before in the past dealing with linear and even this exponential is you still want to put your y1 and y2 values in your calculator. They're already in there, so you don't have to type them in there. But then what you want to do is remember, you go to your second button, that's that colored button. And now, instead of doing the graph, you do the trace. And it comes up with calculate. So once it brings up calculate, I want you to hit option 5, which is intersect. Now, once you do that, you're going to see, it'll say first curve. I want you to hit enter. You're going to see a second curve. I want you to hit enter. And finally, you'll see a guess. hit enter, and it comes up with the intersection mark. So what you should have in this example is you should have x equals 10.021312 and y equals 5.3790531. But remember, it says round to 2 decimals. So at finally, I put down here, so rounding by 2 decimals, it will take 10.02 years, and the population will be the same at 5.38 million. Okay, so this kind of concludes this review. I hope this helps, and have a great day.